Hi everyone, Jim Wright from Toro here. Today's segment we're going to talk about the dwell time of a part circle sprinkler. And the dwell time is the amount of time that it sits at the end of the arc before it returns in the opposite direction. We're also going to talk about some of the nozzling flexibility features and some of the advanced features of the Toro sprinklers, and in particular the Infinity series. So, as we've said in other segments, one of the nice benefits of the Toro sprinklers is the ability to walk up and lift the riser to see what the current nozzle configurations are. You can make any adjustments that you need to simply by lifting up the riser. I'm going to turn this on. And a couple of the features that I wanted to explain is the nozzle-based clutching feature. Again, we can turn this in either direction, regardless of the direction it's turning, or I can hold it for like hot spot watering if I want to put down a little bit more water in a specific deficient area. Neither of those features are available on any of the Rainbird sprinklers. The Rainbird 751, we've got it set up to have about the same arc configuration. Going to get a little wet here. So with the Rainbird 751, you see it's turning in this direction, the clockwise direction. I cannot move it backwards without potentially doing damage, and I can't stop it from rotating. I can feel a clicking inside the drive assembly, and I'm afraid I might cause some damage. So with that, this sprinkler is set up to water probably about a 50-degree angle or something like that. So what we're going to do here is we're going to watch and time the amount of time it takes when it stops at the end of the watering arc. So I'll advance this one out and then back, and it's going to stop along that screen, and when it stops we'll start to count. End of arc trip dwell time is less than 2 seconds on the Toro sprinkler. Somewhere between 1005 and 1006, 5 and 6 seconds, it's sat in that position, applying a significant amount of water, more than what the Toro would. That's basically a waste of water. If you can imagine all the way around the greens where you've got ins and outs and all those part circles are aligned, that area where they overlap and sit is going to be significantly wetter than any other part of the pattern. Okay, now we're going to talk a little bit more about the flexibility features of the Toro sprinklers. And I'm going to start with some of the nozzle capabilities. As we've discussed in previous segments, we have 3 individual nozzles and then some form of back nozzle position that we can individually change to get the water application exactly where we want it to go. So in this instant, I've got a main nozzle that throws about 70 feet. The inner nozzle throws about 25, and the intermediate get out about 50 feet. And I can take this particular sprinkler and change it from a 70-foot radius sprinkler down to a 25-foot radius sprinkler simply by removing the main nozzle, replacing it with one of our main nozzle adapters that has one of the inner nozzles in it, and you just want to get that lined up so that the inner nozzle is in either the 6, 7, or 8 o'clock position. We're going to replace the intermediate nozzle that normally would throw 50 feet. We'll put another inner nozzle in its place, and again adjusting it so that it's in the 6, 7, or 8 o'clock position. I'll leave it at the 8 o'clock position. This one's about 7, this one's about 8. So that's preventing the area directly around the sprinkler from getting oversaturated, too wet. So with this, we now have 3 inner nozzles, and I'll turn it on now, and you can see the effect. Remember, the other sprinkler was throwing about 70 feet. Now you can see the effect of the 3 inner nozzles. We're throwing out 25, maybe 30 feet distance for those very short radius applications. Things like tee boxes, surrounds, any place where you need to shorten the radius, the Toro sprinklers provide a significant advantage. Now we're going to look at the inside of the Infinity Smart Access compartment. Again, the Infinity has all of the components accessible from the top of the sprinkler. I'm removing the what would be 3 screws normally from the compartment. The cover is replaceable, so should an aerifier knock a hole through this, you can replace this independent of the body. Sprinkler comes with an accessory kit that includes wire splices, and all of the wire splices, wiring is going to come up through the bottom of the sprinkler. Splices are going to happen above the sprinkler and then will be tucked back down into the compartment for future accessibility. No longer are any of the wire splices made in the moist soil that might be surrounding the sprinkler. So that's going to benefit all systems, but in particular 2-wire systems. This particular Infinity sprinkler is outfitted with one of our GDC modules for the 2-wire systems, and the GDC module slides into a compartment, into a channel right inside the compartment. So that's the intelligence of the GDC sprinkler. And then the pilot valve is also accessible from the top, and it can be serviced without turning the water off. So I'll demonstrate that now. So as I'm unthreading the screw, you can see the pilot valve is moving up with the screw until it reaches a stop point. There's a checked ball that the pilot valve attaches into, and once that ball is seated, it would prevent the hydraulic valve from operating. So now I have accessibility to all of the internal components without having to go to a lateral and shutting the line down. Now, for troubleshooting purposes, the valve that's in all of the Toro sprinklers is really hydraulically operated. The pilot valve requires an electric signal, but we turn it on by venting water so that it turns on, and then we shut off that venting for it to close. Now we can determine whether this valve is functioning properly with all of those components removed simply by pushing down on the check ball. When I do that, the sprinkler should turn on. When I release the ball, the sprinkler should shut off. If it goes through that sequence like that, the valve that's in the bottom of the sprinkler is working perfectly. So we'll get a close-up of this. So I'm gonna push down on the check ball, and when you do this, there's going to be some water coming up, so you need to kind of cover that up a bit. Push down, valve should come on. Release, valve should shut off. By doing that, I just identified that the valve that's in this sprinkler is working properly, and if I was experiencing some other problem, it is probably somewhere in either the pilot valve, GDC module, or somewhere else in the control system. Now the future is really the key for the Infinity sprinkler. It is the platform that we will be developing all the future enhancements for. One of the first things we're looking to do is a pressure gauge arrangement that can be installed in place of the pilot valve. And what we do is we slide it into the pilot valve position. And with a longer screw, so with the pilot valve in position and in the auto or off mode, sprinkler will remain off, and the gauge to the left is now showing what the mainline static pressure is. This is currently reading about 110 psi. So now I know that the water pressure coming into the base of the sprinkler is adequate for the sprinkler to perform as expected. Now when I put this into the on position, sprinkler is going to turn on, and now the right pressure gauge is going to indicate the pressure that the pilot valve is set to. And in this case, as I look at it, this is set at about, it's running at about 65 psi, which is the pressure setting that we have on the pilot valve. So this is a future enhancement that we're working on now that we hope to have available to customers soon. The compartment that we have here is sized not only for the GDC module, which is the current intelligence module that we use, but for future sensing capabilities that will also be housed in this compartment in some of the other areas where you see some of the other guides. So we already have plans for future technologies that will be inserted into those positions. So basically that's the platform for the future. With the current Rainbird 751, the IC module, which is equivalent to our GDC module, would be installed on the pilot valve, sticking off the pilot valve about this far, buried in the dirt, all wire splices in the dirt. If anything had to happen to this, you'd have to dig it up to get to it versus taking the cover off to gain access to these components. So much more flexibility, much more future-minded, with many more features already than what the existing Rainbird 751 has. Thank you.